really excited to hear about Yogi's work. He's working on determining short-term benefits of cover crops in weed management, soil moisture dynamics, nitrogen credits, and determining optimum nitrogen and phosphorus rates for industrial hemp. So I'm going to hand it off to you, Yogi. Please go ahead and take it away.
Thank you, Dr. Thompson. Thank you so much for introducing me. As Dr. Thompson mentioned, my name is Yogendra Upadhyaya. I'm from Nepal, and now I'm working on cover crops benefits at the University of Florida. I'm located at West Florida Research and Education Center in Jeff, Florida. So let me do, okay. Is this okay? Okay, I think it's okay.
Perfect.
So, okay, thank you. So today I'm going to talk about it's basically about the benefits of cover crop, how cover crop affects the weed suppression, soil moisture dynamics, and what is their effect on subsequent crop yield under the no-till system. Okay, let me give you some, let me start with you a brief introduction about the cover crops given by Scheer. So they define cover crops as a source to slow down the erosion, improve soil health, enhance water availability, and control weeds. Also helps to control pests and diseases. And they believe that the cover crops increase the biodiversity and bring other benefits to our farm. So cover crops, as I mentioned earlier, they suppress weed, they improve the soil nitrogen cycling in the soil, and ultimately they increase the crop productivity. Inclusion of cover crop in our cropping system also improves the farm profit. They help to improve the farmers' livelihood by increasing the farm profit. And cover crop adoption is a challenge nowadays because the price of the cover crop seeds is increasing, and farmers are adopting cover crops, but to make them to make the adoption in a larger scale, we need to incentivize farmers, and there are some organizations like NRCS, and they are providing the incentive to the farmers through the cost share programs, and which is really beneficial for farmers for cover crop adoption. And cover crop also reduce the use of herbicide-resistant weeds, and they could be potential for integrated weed management because they can play a great role in weed management by suppressing weed through different means. It can be whether by releasing allelochemicals or other different means by blocking these sunlights or any other means. But all those weed suppression depends on the type of cover crop. What type of cover crop species we're applying in using in our field, whether it could be like cereal rye or any other legumes or mixture of all those cover crop types. And the with suppression, ability of the cover crop depends on the cover crop species. And if we want a good weed suppression from the cover crops, we want a high biomass producing cover crops and slow decomposing, because if we have slow decomposing cover crops, the prolonged weed management could be achieved through slow decomposition. So let me give you some problems in Florida. Florida has a sandy soil, and it is very prone to erosion, basically wind erosion. The picture on the top, I'm not sure if you can see it clearly or not, but the major reason I put that picture over there is I capture a wind erosion on that picture. And especially if the soil is left barren after picking peanut or harvesting cotton for a long time, and during the month of, I think, February to March, it's going to be really windy, and the topsoil is going to be blown away by the wind, and it's a major problem. And the picture in the bottom, I put that because the field is full of cover crops, and from that field there's no chance that the wind can take the soil away. So we can see a good benefit of the cover crops in those two pictures. On the top, there is a wind erosion. All the soil is carried away by the wind. And also another problem in Florida sandy soil is nutrient leaching, and and the cover crops like cereal rye could be a potential source for scavenging all those nutrients which could be leaching in the groundwater. And because of these reasons, the cover crop could play a significant role to control the wind erosion and also the nutrient leaching in Florida. So today, in my presentation, basically, I'm going to try to answer these three questions. And the first one is how, cover crop biomass and pre-emergence herbicide affects the weed population in cotton. And the second one is, does cover crop has any, effect on soil moisture dynamics, whether it improves or, whether it doesn't do anything in the soil moisture. And also the third one is, does cover crop really increase the cotton yield? So basically, all I'm going to talk about the cover crops. There is nothing else other than the cover crop in my presentation today. So the basic three objectives of my presentation today are to understand the effect of cover crops and pre-herbicides on weed control, and also to understand the soil moisture dynamics with different cover crops and their management practices. And I'm also trying to determine the cotton yield using different cover crops and their management practices. So the experiment was conducted in West Florida Research and Education Center in Jay, Florida in 2021 and 2022. And we're going to do the same experiment in 2023 as well. But today in my presentation, I'm just going to cover the data from my first year experiment. The experiment was carried out in a red-based sandy loam soil in Florida. Excuse me. And before planting cover crops, we did soil sampling at two depths, 0 to 15 and 15 to 30 centimeter. And we try to get the fertility recommendation from the water slab, and basically to get the base fertility of the soil. And we did not put any nitrogen on the cover crops, but we try to put the phosphorus and potassium to meet the nutrient demand, basically focusing on our subsequent cash crop, which is cotton in our case. And normally in ours, the soils in the part where I am right now in West Florida, they are really high in phosphorus. So most of the time we do not use phosphorus, as a basically for a couple of years. Maybe after some years we may have to, but in my experience, we are not using that high amount of phosphorus in our field. So we planted our winter cover crops using grain drill at 7.5 inches spacing, and we did all the germination tests and try to get our exact seeding rate. My experimental design is a randomized complete block with a split plot design with 4 applications. So the main plot factors of my experiments are 4 cover crop types. The picture on the top is the rye, and then another one is clover on the bottom, and one is fallow, and one is clover rye mixture. For the rye, we use 60 pounds per acre seeding rate, and for clover, we use 25 pounds per acre seeding rate. That's for the solo rye and solo clover. And for the mixture, we use 30 pounds of clover and 20 pounds of 30 pounds of rye and 20 pounds of clover. And I have the saw plot, which I call the management practice as a 2 termination methods. The picture on the top, that is standing, and the picture on the bottoms, they are the rolled. So 2 management practices, the 2 subplot factors, or the 2 management practices are rolled versus standing. The cover crops were terminated using the glyphosate, and then after we rolled the cover crops. So half of the field was rolled and half of the field was left standing. So 2 management practices. So now the maturation method that I described earlier, they are common for all of my 3 objectives. So now I'm gonna guide you through each objectives individually. The first objective is to understand the effect of cover crops and pre-herbicides on weed control. So the main plot factor and the subplot factor, the main plot factor cover crops and the subplot factors are cover crop termination methods are the same. But for for wheat portion, I introduce another subplot factor. That's a herbicide treatment. So we use pre-herbicides, and we have another subplot factor, that's no herbicide. So we just want to see if there is any benefits of cover crops. If we use cover crops and herbicide, we just use only cover crops. So we use dual magnum as a pre-herbicide, and we also use the post herbicide to control the weeds, Roundup and Liberty as a post herbicide to control weeds. So the data for the data collection, we use 1 meter square quadrant for the data collection. And before the application of the pre-emergence herbicide, we cover 1 meter square area in each cover crop, management practices like roll versus standing. We use the 1 meter. We cover the 1 meter square area with a tarp to try to get the data from that 1 meter square area where there was no any herbicide applied, because the tarp is covered and there's no any herbicide applied on that area. So basically, we focused 1 meter square area where the tarp cover is for the no herbicide applied area, and we selected another space on the same plot where we called it as a herbicide applied area. So we try to compare the wheat population between no herbicide applied versus pre-herbicide applied. So I try to get the data from the plot for different weeds like Texas panicum, tropical spiderwort, sickle pearl, and also other weeds like other several weeds. But today I'm just going to talk about Texas panicum and tropical spiderwort. And let me tell you, these two are one of the problematic weeds in our place, in our area when I'm located. So, and sickle pod is also another problem over there, but tropical Texas panicum and tropical spiderwort are the major problems in our area. So for the weed count and for biomass, we did the weed count from 1 meter square area at 2 and 4 weeks after planting cotton. And weed biomass was harvested at 4 weeks after planting. And we also did weed count at 2 weeks after post application. And for the statistical analysis, I use proglimics in SAS, and for the mean separation, I use LST at alpha is less than 5%. Sorry, 0.05. So this is the graph that can give you an idea about the cover crop biomass that we get in our field. So the clover is clover biomass, rye is rye biomass, and I separated the biomass into rye and clover in the mixed plot, because the mixed plot is a combination of rye and clover. So I separated the biomass in the mixed plot to give you the idea how how the biomass is distributed according to different species in the mixture as well. So this is just to give you an idea about the biomass production. So let me guide you through the the weed density of tropical spiderwort and Texas panicum between the two management practices. So if we look at the graphs, we did not see any significant difference between two management practices. There is no any significant difference between roll versus standing in terms of Texas panicum density, and it's the same thing with the tropical spiderwort as well. We didn't see any significant difference between the tropical spiderwort density as well. And if you look at the error bars, you can see sometimes the error bars are so high, and maybe because of those high error bars, we may not have seen the statistical significant. And it's really hard, to find the uniform wheat population in the field. In some part it is too high, and in some part it's low. And we just use the natural wheat population in the field, and we did not use any seeds by ourselves, so it's all natural population. And I assume with all natural populations, and there's always going to be a variation in the field. And also with the pre-herbicide application and no herbicide applications, that means between the cover crops and pre-herbicide, we did not see any statistical significant difference in terms of Texas panicum density. So basically the pre-herbicides and the cover crops have the similar weed control for the Texas panicum. For Texas panicum biomass, we see a significant higher, Texas panicum biomass in clover rye plots. And but other than that, there's no any statistical significant difference in terms of pre-herbicide versus no herbicide applied, even in terms of Texas panicum biomass. So for topical spider wort density, it's pretty much the same like Texas panicum. We did not see any statistical significant difference between the pre-herbicide versus the no herbicide applied area. No herbicide mean the cover crop used area. So there is no any statistical significance between the pre-herbicides versus no herbicide for topical spider wort control. And also, if I wanna talk about the topical spider wort biomass, and I see the rye has numerically lower biomass production. That means it controls the topical spider wort biomass production. But I see numerical difference, but there is no any statistical significant difference if you compare with the fallow or clover rye. But there was a statistically significant difference between clover and rye in terms of topical spider wort biomass production. And I believe it could be something to do with the early season, the nitrogen released or mineralized from the clover plots that could have contributed maybe on the biomass production of topical spider wort. So okay, so this is at 2 weeks after post herbicide application. So if we compare the number of Texas panicum, Texas panicum density, I would say, between the rolled versus standing cover crops, the management practices 2 weeks after post application, I didn't see any statistically significant difference between all those cover crop types and management practices, and it's because of the variation. The error bars are so high, and also I just use 1 meter square area for the data collection, and maybe to reduce that variation, I could have increased the sample size maybe to 1 meter square area, and thinking that this year I increased the sampling area. So rather than using just 1 meter square area, I used 2 1 meter square quadrants per plot to get the weed density. So that my assumption that I will try to minimize that variation that I'm getting right now on those graphs. So for number of topical spider wort control, I didn't see any statistical significant difference. It's the same story with the topical Texas panicum density. So the error bars are high on that one as well. And as I mentioned earlier, it's because all the natural environment, natural weed population over there, and we had those conversations before with my advisors and other people as well, because of all those variations, and they said, like, the one of the best way could be we can put the weed seeds over there. And on my part and my experiment, it is a big cover crop trial, and it's pretty hard to put the seeds from outside and try to get the weed data, basically by putting the seeds in the weed seeds on the ground in my experiment. So in the conclusion of the first objective, I just want to share we didn't see any statistical significant difference between the cover crop species and termination methods on topical spider wort and Texas panicum density. There is no any statistically significant difference between the pre-herbicide versus no herbicide. So that means our cover crops really works great in terms of weed control. So especially early season weed control, like first 2 to 4 weeks. Which is really important for the crop growth as well. The early season weed management is one of the crucial part for the crop growth. And if we don't control the weeds in the early season, I mean, it can reduce the crop yield. So cover crops are, really taking a great care of the weeds, like they are controlling the weeds in a good way. At the same time, the tropical Texas panicum biomass was reduced with the pre-herbicide application also. So now let me talk about the objective 2. So it's about understanding the soil moisture dynamics using different cover crops and management practices. So I said cover crop types and management practices. The cover crop types and management practices were the same as I described earlier. The cover crops were those 4 cover crop types: clover, rye mixture, and fallow. And the management practices means the 2 termination types, roll versus standing. So for monitoring soil moisture, we use Hobo multi-depth soil moisture sensors. These sensors were designed in such a way that they can, collect the soil moisture from 3 different depths: 0 to 15, 15 to 30, and 30 to 45 centimeter. And they are automated systems. We can get the data on the cloud, and it's handy. But those soil moisture sensors, they always have some issues, like sometimes they were not communicating. Sometimes we may not be able to get some data, like for a couple of days, and then we go to the field and try to fix the problems, and there's a big chance of losing the data as well. And you will see those data as like how it could be a problematic in the graphs that I'm going to present in the next slide. And I made those the graphs were generated from RStudio, and Resham, one of the member of PSA, he helped me on generating those graphs, and I may have to work more on that graph in the future, and I'm expecting some suggestions from you all today as well. But I'm going to talk about those graphs more today on basically on the soil moisture portion. So as you can see on the graphs, at all three depths, the cover crops are really increasing the infiltration, and as compared to the bare plots, the fallow plots. And if you can see the graphs, can you see my pointer on the graph?
Yes, we can.
Okay, so these peaks are the rain events. These peaks are the rain events. So when we get the rain, we can see high infiltration in the cover crop plots. So it's the same story with both rolled and standing. Both rolled and standing cover crops, they really they really increase the infiltration of water in the soil. So both of the cover crops are greatly improving the soil infiltration. So they are beneficial in terms of soil moisture. And also the main part here I want to show you is this later part in the season. So I mean, we can argue that in the later part of the season, like when the a crop may not need that amount of water in the later season, but the main idea I want to focus and I want to explain to you is that these couple of weeks, like 7 or 8 weeks around this region, even on this side, these are the drought season in Florida. So these 7 and 8 weeks, we didn't get any rain events, any rain events for those 7 or 8 weeks. So even if we did not get any rain, you can see how cover crops are conserving the soil moisture in those weeks, those weeks time periods. The fallow is really low in terms of water content in the soil. The cover crop is still doing pretty good in terms of holding their water in the soil. So what I mean to say, the cover crops could be really of great importance. If we have long drought, if we have drought areas, they could be one of the greatest tools for the farmers for soil moisture conservation. And there's no doubt the cover crops can improve the soil moisture compared to fallow. At the same time, for the drought areas, the cover crops are really, really great for improving soil water holding capacity. That I can say from there. But I cannot say anything about which cover crop is improving soil water in a greatest content. But Overall, cover crops are improving soil water content, and at the same time, in case of drought, they are really, really great for conserving soil moisture. So finally, for summary and conclusion of this objective, I want to say cover crops help in soil moisture conservation. They conserve soil moisture at different depths. Both cover crop management practices, its roll versus standing, and all the cover crop types, they improve the soil water infiltration and helps in soil moisture conservation. And especially in case of drought events, if we have prolonged droughts for a couple of weeks or in the drought areas, they could be really beneficial for conserving soil moisture. So for objective 3 is to determine the cotton yield using different cover crop and management practices. So in this objective, I'm gonna just talk about the different cover crop types only. We have soft subplot factor as a nitrogen rates as well in my experiment, but I'm not going to talk about anything about the different nitrogen rates. Today, I'm just going to talk about the cover crops. So I just use the data from the 0 nitrogen plots. So there is no nitrogen applied on those plots. So it's basically all about cover crops and those management practices. So cover crop types and management practices are the same. As I mentioned earlier, the cover crops types were all those 4 cover crop types. Cover crop types: clover, rye, mixture of clover and rye, and fallow. And the management practices are roll versus standing. So these are the 2 management practices. And for cotton, we planted next generation cotton. In my experiment, we use a monosem planter. And I just want to share you the problem that I faced while planting in that huge cover crop biomass in the ground, laying in the ground. And that monosem planter, we try to make it fit based on our scenario. We try to fit with a quarter in front of the in front of the planter, but it didn't work. So I have to go there and do some gap filling with myself and a couple of my friends, and it took us several days to fill those gaps because we don't have no-till planter with us in Florida, the place where I am at right now. So we have to use that planter, basically the monosem planter, and it did not put all those seeds in the ground as deep as they are supposed to be. So some seeds were laying on the top, and they were all over, and most of the seeds, they did not come up. So I have to go and the gap fill, and once all the crops are up, and then I have to go there back again and try to do thinning. So that's a challenge for me over there. So I try to measure the leaf area index, and for leaf area index, I measure around flowering time, and we use cotton picker, and we pick two middle rows of the cotton. That's normally we do. And for this objective, I use the RStudio and Agricoli package for the statistical analysis, and Fisher's LSD for the mean separation. And if I want to talk about the leaf area index between different cover crop types, the leaf area index was significantly higher in the mixture plot compared to the fallow and clover. And also, there's no any significant difference between the rye and clover mixture. And if we compare between the two management practices, roll versus standing, I did not see any statistical significant difference in terms of leaf area index. So they have a similar leaf area index. And also, I just want to let you know that the termination of the cover crops were done like three weeks earlier, like 3 weeks before planting the cotton. So maybe the clover may have started, mineralizing the nitrogen and releasing it into the soil earlier than the time when the crop needed it. So there could be some difference between releasing the nutrient in the soil and the time for the crop to take it. And it could be I think the main idea, what I think is, like, the role between roll versus standing, because if we roll the cover crops, it's gonna be at the soil level, and the decomposition could be faster because it is touching the soil, and the soil microbes could act on it, and the decomposition could be faster. And for standing, it's gonna take some time for that biomass to get on the soil, and then and after that decomposing. So the main idea, I just want to see if I can capture any the difference that I just mentioned, but I didn't see any difference in terms of management practices. So if we compare this is basically the seed cotton yield, not the lentil, but the seed cotton. And if we compare the seed cotton yield between the different cover crop types, I did not see any statistical significant difference. Although looking at the bars, we can say there is some numerical difference, but no any statistical significant difference between these cover crop types. And also between the two management practices, I did not see any statistical significant difference between standing and roll cover crops. So in conclusion, I just want to say the leaf area index is higher in the mixture compared to the clover and the fallows. But between the management practices, we did not see any statistical significant difference for leaf area index, and we did not find any statistical significant difference between the cover crop types, although there was a minimal numerical difference, and no any statistical significant difference between the management practices for the seed cotton as well, seed cotton yield as well. So all these three objectives are part of the PSA cover crop trial. So, and in that big trial, I try to fit all those three objectives. And other than that, I'm also working on determining the vegetation indices, especially the normalized difference vegetation index and normalized difference age index on the cotton that I'm working on the cover crop trial. So that's one of the work that I'm involved right now. And also we are working on determining the optimum nitrogen rates and phosphorus rates for industrial hemp production in Florida, and we are using a couple of different varieties and a couple of different nitrogen rates and phosphorus rates, and get a optimum nitrogen rates for those industrial hemp production in Florida. And I'm also working on another project. It's basically on cover crops, and I'm using different nitrogen rates, and try to get a different level of biomass, and try to integrate that with different herbicide combination, and try to find a based integrated management approach for weed control. That's the project that I'm involved, other than the connection with our PSA group. So these are all the projects that I'm working on. And finally, I want to thanks to my advisors and my committee members, and the Weed Science and Cropping System crew at WFREC, farm crew. And I want to thank the Precision Sustainable Agriculture team and USDA NIFA. And thank you so much, all of you here, being here today. And I'm very much enjoying the company from you all, PSA group, and I'm ready for the questions and try to take suggestions as well. Thank you so much.